Hello and welcome to episode 36 of the Primary Maths podcast, the show where we talk all things primary maths. I'm Jon Cripwell.
And I'm Becky Brown.
Hello, Becky. How are you?
Hello, I'm good, thank you, Jon. It's been a busy week, but a good one. Yeah, all good here. How about you?
Yeah, it has been a busy week. I have been catching up with Stranger Things on
No
Netflix.
spoilers.
Okay. No.
Haven't watched it yet.
It's probably beyond the remit of this podcast, I have to say. However, I think if I can find some maths in it, then we will discuss it at some point. But yeah,
I think we can do that. That's a challenge for us.
Yeah, I think
Find
so.
the maths.
It's had me gripped this week. So I love all that sort of nostalgia for, yeah,
Oh,
80s,
me too.
Steven Spielberg inspired, it's almost that time of the year again, isn't it, to dig out Gremlins and things, because Gremlins is clearly a Christmas movie.
Christmas movie.
Becky. Yeah, well, it's set at Christmas. And
it counts.
I think so, yeah. It's got carols in it and everything. So I think, Gremlins, Die Hard, definitely Christmas movies for me. So that's what I've been doing, as well as obviously thinking about maths and talking to people about maths. And I was lucky enough to speak to the wonderful Rob Easterway for our interview this week. So if you missed that, go back and have a listen. Becky and I will be discussing exactly what we talked about later on in this show. But it was a great listen. Rob is a fantastic maths communicator, talking about how he brings maths to life and makes it, feel sort of real and tangible, I think, and sometimes maths can become a little bit abstract, can't it, when we're teaching it? Necessarily so.
Yeah.
But I do like the way that Rob sort of brings it to life and inserts a little bit of magic back into it. So go and have a listen to that if you haven't already. He also, obviously, Becky, incorporated a little bit of history into the conversation, which obviously I particularly enjoy. Because
we do love a bit of history of maths.
Yeah, it's the Primary Maths podcast with a sprinkling of history where relevant. Because I find history fascinating as well. So that was my conversation earlier this week. As I say, go back and have a listen. If you have missed it, maybe it's because you haven't yet subscribed. So while you're there, just hit the subscribe button. Follow us on YouTube, on Apple, on Spotify, on all three if you wish, just to make sure you never miss a moment. So, Becky, I was delighted to have an email this week from Sam Asplin, who is a Year 4 class teacher and school maths lead at Ketton Primary School. I don't know whereabouts in the world Ketton Primary School is, actually. Does it ring any bells to you?
Not familiar to me, Jon, no. I was very excited, though, to read the email. It was, it's always lovely to get emails from listeners, isn't it?
It absolutely is. Yeah. So Ketton Primary School is in the heart of Ketton Village, which is in the county of Rutland. So not a million miles away from where I am in Derby. But he had this to say. It was a great email. He sent a couple of photos with it as well, actually. He said that he told us that he loved the podcast. I mean, I think that goes without saying at this point, Becky, don't you? But he went on to say that he wanted to email this random maths encounter he had this week with one of his pupils at our after-school snack time, as he thought it was an interesting example of everyday maths of life style non-examples, similar to the discussion that I had with John B. A couple of weeks ago on variation theory and task design. So he says, a Year 5 pupil made me smile when she asked for a cheese square when referring to the packet of Dairylea cheese triangles on the table. And these are actual Dairylea in the picture, actual Dairylea cheese triangles, Becky. I mean, that says something, I think, about Ketton Primary School's after school snack time. They are, branded cheese triangles. Sam says here, my gentle teasing of her using of the word square was quickly turned back on me, though, after she pointed out that they're not really triangles at all either. And looking closer at them, I realised that she was indeed spot on. With one definite curved side, they're not a polygon at all, leaving both the label of square and triangle as inaccurate as each other, perhaps. So Sam suggests rebranding Dairylea cheese triangles to Dairylea cheese sectors. And then sort of grumbles. And when we read this, we both agreed, didn't we, Becky? Why do everyday mathematical errors go uncorrected in a world where grammatical errors are pounced upon almost instantly? Just thought that you would also enjoy the 2 minutes pondering that me and my year 5 pupil had over this. So thank you so much, Sam, for that email. And it has, in fact, inspired our topic for today, hasn't it, Becky?
It has. What a lovely incidental maths conversation to be having also. Just one of
Yeah.
those things that just comes about.
They were always my favourite maths conversations in school, I have to say.
Me too.
And it's always nice as well when you correct a people and then they correct you back, isn't it? I
Yes.
think that's a lovely moment in every teacher's life, because they've obviously taken something on board at some point, haven't they? And they have that knowledge now. And Sam is absolutely right. They obviously the cheese triangles are not cheese triangles because a triangle has to have 3 straight sides that add up to where the internal angles sum to 180 degrees, of course. And if you look at a Dairylea cheese triangle, as they're called, it does have a curved side because when you put them all together in the packet, it makes a circle, doesn't it? So I was double checking what it would be, and a sector is a 2D shape. So this would actually a cheese triangle is actually a cylindrical sector. So they really should be Dairylea cylindrical sectors.
I'm not sure how that worked with branding. It doesn't really trip off the tongue, does it?
Not especially. Are you a fan of Dairylea cheese triangles or
Do you know what? I
cheese?
haven't had a cheese triangle for years and years and years, and I really want one now. So maybe they will make it to my shopping list this week.
I was going to say, Dairylea, if you are listening, I'm not particularly a fan, but Becky clearly is. So if you did want to, send some free samples of Dairylea cylindrical sectors, send them Becky's way, please. Happily provide an address if you email us primarymathspodcast@twinkle.co.uk. So, Becky, we did say, didn't we? Well, you said actually that this is something that really grinds your gears.
Yes. I mean, I am also the person who likes to spot grammatical errors as well. But I think Sam's right. Actually, you see that a lot more, don't you? See a lot of people picking up on people's grammar, the grammar police, and not so much in maths. But I think I said to you, I could talk about mathematical misuse and misconceptions all day long, because I think with the maths, maybe it's harder to spot, but it is definitely out there.
Yes, definitely out there. And so we have chosen our favourite mathematical common misuses. I say favourite, they're not your favourite things, are they, Becky, to be honest?
Anti-favourite, maybe.
Yeah, the things that wind you up when you see them out in the wild. I'm a little bit like that with punctuation as well. So grammar and punctuation for me, apostrophes, a real bugbear. I remember reading about somebody who was going around with correcting signs, like shop signs and things, putting apostrophes back in, and yeah, they're a little bit of a hero to me.
But more often rubbing them out. I have been known in a pub before to be rubbing out chalkboard apostrophes. It's easily done, that one, isn't it?
I mean, I'm going off on a tangent here, but I was at somebody's house for a lovely bonfire party, fireworks party, and they had a sign saying, one of those signs in the kitchen, the sort of signs that you get in the kitchen somebody's bought for them, and it said, what happens at Nanny's house stays at Nanny's house. Right? The first Nanny's had an apostrophe. The second Nanny's did not have an apostrophe. I mean, what is that all? At least be consistent, or just hedging your bets, possibly. But we are going to do the same thing now with mathematical misuses and mathematical errors. So do you want to kick us off, Becky? What's made it into your list?
Yeah, I'll go first. A difficult list, actually. I could have probably done 10 things, but I have narrowed it down to 2.
This is a 12-hour episode of the podcast.
Yes.
Becky's just going to rant now for the next 11 hours and 45 minutes.
Yeah, I think the first one, often it's misused, but sometimes it's just that it isn't used in a mathematical way, maybe, is around probability, and specifically probability around lottery numbers, because we often hear people saying things like, oh, my numbers haven't come up yet. They must come up soon. They must be due. And I think there is this sort of belief that if a number hasn't come up for a while, it's going to come up soon, which of
It must
course,
do, Becky.
mathematically.
Intuitively, it must do, surely.
Well, funnily
Surely.
enough, I've had a similar conversation with my class. We were playing the dice game as a maths starter this week, and we kept rolling the number 6. And it was like, oh, we can't keep getting 6. We can't have another 6. We've already had too many, which opened up a nice little discussion around actually we could still have a number 6 because the chance, of course, is exactly the same, completely independent of how many 6s have come before. And it's the same with the lottery. I think lots of people do the same lottery numbers, of course, each week, not necessarily because they think it's going to increase their chance of winning, but maybe they have a meaning to them, or they're just worried that if they start doing those numbers and then they stop one week and then they came up, that'll be awful because they would have won. But there is definitely a belief, I think, and I'm a bit guilty of it. I will say I've spent quite a bit of time in Las Vegas in my life, and you do get playing roulette is a bit like that. You're like, oh, there hasn't been a black number. Afraid that there's got to be a black. It's got
Well,
to come up. It's got to.
yeah, I mean, interestingly, this is actually referred to as the gambler's fallacy, or sometimes the Monte Carlo fallacy, or even
Yeah,
the fallacy of the maturity of chances. And it's all about when something has happened less frequently than you expect, you believe that it's more likely to happen again
yeah,
soon.
and
And you're
and
spot
even
on. It's a
though
recognised thing.
mathematically I know that is not true. That's not how probability works. They're completely independent events, but you still do, I think, because we look for patterns, don't we? That's what we
Yeah.
like to do. We like to find patterns and symmetry and things. So I think it's an understandable thing that people get wrong, but it's still a little bit annoying.
It's because, as you say, we look for patterns, we look for things that we expect to happen in a certain way, and when they don't, they stand out, don't they? Apparently, the
Yeah.
Monte Carlo fallacy originates from an example of this happening um, in a casino in Monte Carlo in 1913, where the roulette wheel spun black 26 times in succession. I mean, you can imagine, can't you? After it had done that 3 or 4 times, everybody's putting their money on red, aren't they? Because they're expecting it to come up red
Yeah.
next time. And so I bet a lot of people lost a lot of money that night
Yeah.
in 1913.
And by the time it
Because
eventually did come up, they probably were out of money and had left the table. It's all
exactly,
gone.
yeah, the house won yet again,
Yeah.
as is always the case. So yes, so the gambler's fallacy, totally agree with you on that one. But it is hard to separate our sort of pattern spotting, that human nature of it, isn't it?
Yeah.
As you say, even when you're trying to be rational about it. For me, my first one is the misunderstanding around averages, and how averages can be really, really skewed depending on which average you are looking at. So there can be a massive difference between the mean average and the median average, and what those things can show you and mean. And I think it happens quite a lot in politics. That old saying that you can prove anything with a statistic, I think relies quite heavily on averages and how you read
Yeah.
averages and things. So it's and obviously famously you'll remember Michael Gove talking about all children being above average. Averages, I think, are just not well understood, are they? And the idea that the average salary in the UK, I think, is something around £35,000, but the median is closer to £27,000. So that's a big difference, isn't it? And you could spin those averages either way, um, any way that you want to.
Yeah,
Um,
it's another statistics one, isn't it? It's probably not luck that we both come up with statistics based ones so
yeah,
far. Um, Definitely, and I think average is one of those words, isn't it, which is used a lot in a non-mathematical context too.
yeah, yeah, yeah. And yeah, I just think they can be really misleading, and we accept them far too readily without really asking well, where's that average come from? What does it actually mean? What's the data behind it, and why are you presenting that particular statistic? And I think just it's good practice, isn't it? When we're talking to children and telling them not to believe everything you read on the internet, and nowadays with AI and things, there's quite a big push to not believe everything AI tells you and to question things and look for the sources. I think we ought to do the same sort of thing, really, when it comes to statistics and averages, and just teach children to just question, what does that necessarily mean? We were in a pub a few weeks ago with some friends, just having lunch, and we were talking to children about maths. I do talk to them about other things, Becky, occasionally, but my daughter was saying that the average number of legs of the occupants of the pub was greater than 2, and I was saying, what are you on about? And it was because there was a dog. There was a dog sat by the fire, and so she's, assuming that everybody else had 2 legs, I suppose. But she was sort of saying that skewed it, and she was very clever, very pleased with herself. This is my older daughter, for
Yeah.
pointing this out. But she was just sort of pointing out that averages can tell a misleading story. It's not like everybody in the pub had slightly more than 2 legs, is it?
Yeah.
So,
Yes.
so
I
yeah,
think,
be wary of averages, I would say.
yeah, I think people also get paid quite a lot of money to make the averages work in their favour, don't they? Or make the statistics work in their favour.
Yeah,
So
yeah,
definitely something that needs to be taught, I think.
absolutely. Right. 2 more then. What's your next one?
So leading on, actually, and I think this is one we do tend to see in politics quite a lot. So I'll just be careful about which examples I share for this one, John. And slightly outside the remit, possibly of primary education, but definitely maths, is getting mixed up between correlation and causation. Another statistics one, unsurprisingly, maybe. So correlation is, of course, when there is a relationship between 2 things happening, but causation meaning one has caused the other. And often a correlation can be explained as a causation. So for an example, an education-based example for you, often we hear things like, well, children that do homework will perform better in their exams. Well, that is a correlation. Yes, that is the case. If they do homework, they are more likely to be better at exams. But it's not doing the homework necessarily that causes them to perform better in exams, of course. The sort of children that are doing their homework, or the households maybe that put that as a priority, are children who might work harder to get those better grades. So there's some sort of third party things. There could be millions of other things, of course, that could feed into that as well. But that's, it's more down to motivation than the homework itself is what is making better
Yeah. We're straying
students.
into primary science, aren't we? I think STEM conversations within our family of podcasts, Twinkle, might have something to add to this, and maybe we should mention it to them. But it's an interesting one, isn't it? And I know from that it's something that scientists particularly and data analysts struggle with all the time, is with people particularly trying to really nail down what the data is telling you in terms of causation rather than correlation. I know with looking at things like diet and its impact on health, it's really, really, really hard to do, because people aren't always honest about what they eat, but also, if you do happen to be the sort of person who likes to have a leafy green salad for their lunch each day, and doesn't eat processed food and doesn't have takeaways, you're probably also likely to be the sort of person that exercises more frequently, or watches less TV, or eats less sugar in general. Do you know what I mean? So
Yeah.
there's all those other factors, aren't there, to take into account, and it can be really hard to dial down onto exactly what's causing one thing or the other. So looking for that causation can be tricky, as you say,
Yeah. And
Becky.
I think that's what the issue is, isn't it? That causality is really hard to prove unless
Yeah.
you're living in a very controlled study, which life isn't a controlled study. It's very hard to prove the causation of one thing over another, where the correlation can be really easy to see. And
I
again,
think,
nice
yeah,
patterns.
I think it's about, can you see a mechanism for one causing the other. So with your homework example, possibly you can see a mechanism of why the homework might help children to pass exams. But I think if you delve into that a little bit more, it probably becomes that mechanism becomes a little bit flimsy, doesn't it? Because the homework just isn't necessarily going to lead to a higher exam outcome. And if you look at some other studies, you probably see that there isn't a link. So yeah, it's trying to nail it down with people. It's just really, really difficult.
So, of course, I delved deeper and found all sorts of causation and correlation stories online, particularly. But one I particularly liked was linked to the old European myth of storks delivering babies. So, sorry, John. That should have come with a warning, shouldn't it? Sorry.
Yeah, especially this time of year. I don't want any
Yeah.
other myths dispelled, please, Becky,
No,
on this podcast.
absolutely not. And so in rural areas, so stork have large stork populations and they correlate with higher birth rates, leading to, or perhaps backing up the belief of storks bringing babies, the mistaken causation being that one caused the other. But of course, it's just that rural households tend to be larger and have more habitats that might have a stork population. But I quite liked that one. Not anything to do with maths, but quite cute.
Yeah, very nice. My final one then, misuse of maths, is all around percentages being used potentially to mislead us yet again. So I think we just have to be really, really wary. And as teachers, sometimes we are aware of this, aren't we? Because we have to present data as percentages. And sometimes when you're looking at a very small population, say perhaps in some schools, your EAL population might be in a class might be only 2 children out of 30. That's a very, very small population that can lead to huge, if 50%, if one of those 2 children hasn't made age-related expectations, you could say that 50% of the EAL children in that class haven't made age-related expectations. And actually that's just one child. So we need to be quite careful, don't we? Percentages and fractions, I suppose. Uh, Headlines like burglaries up 200% and things. Well, if it's gone from 1 burglary to 3 burglaries, that's not quite the same as thinking about it going from 100 burglaries to 300 burglaries, is it? We need to again delve into the data behind the numbers, behind the statistics a little bit, and see what's likely to happen. Going back to your lottery mention earlier, Becky, 600% more likely to win on a scratch card. Well, if you're going from 0.0000001% to 0.0000006%, that's technically 600%, but still essentially zero chances of winning. So again, just being aware what are these claims based on, I suppose, can help you to avoid falling into believing spurious claims, I suppose.
Yeah, you often see it in adverts, don't you? I mean, not that I watch many adverts on the telly these days; it's too easy to fast forward through them. But often in the small print, they'll have big percentage claims, but often in the small print it will say sample size 75 people, and so it's that's quite telling. That's quite telling. Very small sample size, percentage not as significant. So it's just being aware of it and what to look for, isn't it?
Absolutely. So thank you for that again, Sam. We really appreciate that. If anybody else has got any misuses of maths, perhaps slightly more linked to primary maths than the ones that we came up with, although we will not apologise for that, will we, Becky? Because
No.
it's just the things that made us cross. But if anybody does have any others that they would like to share, or any sort of common misconceptions that they see children believing about maths, then do get in touch, just like Sam did, and let us know, and we will feature it on the podcast in the coming weeks. All of this brings us back quite nicely, I think, Becky, to my conversation with Rob Easterway on the interview earlier this week, where we talked about the maths of life. This is a part of the show where we talk about the key takeaways from that interview, and Becky's had a listen back to it. So what were your takeaways from that particular episode, Becky?
So first of all, John, loved the interview. As a lover of puzzles, as you well know, there were lots of things that resonated with me while I was listening. I was lucky enough to listen to Rob talk at the maths conference as well earlier this last month. So yeah, really interesting to listen to. There were a few things that came up. I have narrowed it down a little bit. Rob said at one point about how we don't often use a written method in real life. We often aren't using those written methods. And if you think about, I mean, we're on episode 36 now. We've done a lot of maths of life. I don't think we've ever talked about written methods, or very, very rarely. When we're talking about maths in the wild, we don't tend to think about structured procedures, which is very telling, isn't it? Because I think for teachers, often that is a very big focus of maths achievement, isn't it? And I wondered whether that's because it's easier to evidence. It's easier, isn't it, to say, well, a child can do this procedure than to show their mathematical thinking and evidence that.
Yeah, well, it's also a big part of the national curriculum, isn't it? And the fact that the way that we are assessed, children are assessed, and teachers and schools are assessed in maths at the end of Key Stage 2. You know, there's a whole paper with 36 marks, which is, you know, as Phil Hurd was saying a couple of weeks ago, if you know that we need to get children 50 marks to be at age-related expectations, whatever that means, at the end of year 6, and you've got an arithmetic paper where you can pretty much guarantee what is going to be included in that paper, if not the numbers, you at least know the procedures, then it does lead you, you know, to teaching procedures, doesn't it? So that you can try and help those children achieve those marks that they need in order to pass, in inverted commas, the end of year 6 tests. And we know that what those tests don't check is whether they're good mathematicians or not. They just check whether they, you know, particularly the arithmetic one, whether they can follow a procedure.
And of course, there is a place for procedure. It is a very important element of maths, absolutely, but it certainly isn't the be all and end all, is it? And also, you think, well, once you've learnt a procedure, that's kind of it. There's so much further you can go, sideways as well as forwards. It's just a shame that I think people still look at. I think Rob used the analogy of wanting to match the answer in the back of the book. Yes. And I think often we do that, don't we? We want to get the right answer. And actually, yes, if that's the answer that's there, then I'm right. But we know, and we talked about it lots, certainly in recent weeks, in and out of the podcast, but it's so much more than that. But it's just how to capture that and how to evidence it.
I do think, as you say, that there definitely is a place for written methods. If only as another sort of representation as well of what's happening within a procedure and why it happens that way. It does reveal quite a lot about the structure of our number system and how things work. If we think about multiplication, long multiplication, the way that is done through that procedure is kind of just how you would do it in your head if you could hold all those numbers together in your head, or one of the ways that you might do it in your head, you know, partitioning off the ones and the tens and multiplying those in that way to try and make it a little easier. So it can be a helpful thing to learn, but as you say, beyond school, the chances of you using it very often are fairly slim, and perhaps what we should be aiming for more is teaching children to be fluent and flexible and accurate and all those things in a way that they're actually going to use more day to day. Well, I think one of the things that we talked about actually in the episode was how often we use estimation in real life and how little we do that at school. We do talk about it, don't we? But I don't think we spend anywhere near enough focused time on estimating things and considering whether something is, you know, an answer that we've arrived at is actually a reasonable answer or not.
Yeah, you only need to go back to my suitcase weighing story to know how important that is.
What was that about? Episode 2, episode 1, something like that?
It was a long time ago. It's gone into the dim and distant memory of my past now.
Yeah.
Thankfully. Yeah. I loved talking about puzzles. I think, and Rob was saying when he talked about the book and how I think it was an editor was a little bit, you know, are we really going to sell a maths book? Are people really interested? And I think we're really lucky in today's society, you know, the internet and lots of joined up thinking brings its disadvantages. But the fact that people can be inspired, it's okay these days to be inspired by different things. And being inspired by maths, I think, is just as exciting as being inspired by things that may be a little bit cooler, shall we say. I'll show my age now in the use of that word, John. But yeah, and I think finding inspiration is really important. And he mentioned games, magic tricks, puzzles. I remember when I was doing my GCSE coursework, I mean, this was a long time ago, we're talking 1995, 6. And we were literally given a maths investigation. It was like, well, you can choose from this list of maths investigations and you go and do some coursework on it. And that was when I first realized how much I loved that sort of puzzling. I chose one called Cabbage Patch. I think Towers of Hanoi was in there, all those classic maths things. And it was about planting cabbages in a row within a certain shape. And that was literally all we were given. But I found myself finding all sorts of formulas and things. And to me, that was like magic. It was like, brilliant, this is amazing. And I went further and further. And I think that's where my love of sort of maths puzzles and things go. And it just takes one tiny little thing, doesn't it? Like maybe going to a lecture of Rob's or listening to a podcast that might get you inspired and into maths. And I think it's those real things that inspire people rather than the sort of bones of maths, really.
Yeah, for me, it all comes back to, I think you've just used the word recently, but making connections and just seeing that it isn't about memorizing a formula or memorizing a pattern even necessarily. It's being able to spot things and question and investigate and, conjecture and make generalizations and all those things that are exciting. And, when you hit upon something, it is exciting. And that's something that I think puzzles give us. And something that we could possibly do with a bit more of in maths lessons. Although, as Rob says, also puzzles, we need to be careful with them because some people can't find a way into them. And that can be disheartening in itself.
Yeah, I think when Rob was discussing the tree problem, and I think you had asked him, or you talked about the clarification of language, and he actually said, well, I didn't want it to sound like a maths question. I wanted it to sound like a problem. And I think there's a bit of a disconnect, isn't there? Because in maths, we are so caught up on use of precise language, or we must use this language, or we must make sure we're explaining. And there is absolutely a place for that. That's very important. But when you're really trying to pull apart a problem, maybe we can let go of that a little bit just to make sure that we're not narrowing down what children come up with. So I think that was quite an interesting, it's almost like they're two very different things having to come together, which is not an easy thing to do in the classroom, I don't think.
No. And you always get that child in the class that can be a little bit pedantic about maths problems or puzzles. This isn't realistic. We wouldn't really be purchasing carpet for Mr. Brown's office or whatever. Do you know that when you've given them a problem like that? And I think it's okay to lean into that and just agree with them that, yeah, you're right. It is. This isn't. What would that look like then? And just have some fun with it, I think is absolutely fine. And that's when you end up having those conversations like Sam had with his pupil earlier about cheese squares, cheese triangles, cheese cylindrical sectors, whatever they might be. That's where those conversations come. And those are the things that you remember, I think. And, there's so many opportunities to justify and explain when you have those sorts of conversations that if you just shut it down or you try to be too precise and don't allow for any of those, then I think that's a bit of a shame.
I think we're very used to doing it in other subjects. If you're talking about maybe PSHE, it'd be really pushing for that open discussion. I think just sometimes it's a bit scary in a maths classroom if you don't quite know what the children are going to come up with.
Yeah, but that's okay. It's okay. You can admit that to them as well.
Definitely.
I on a daily basis, my children found out that some of them were cleverer than me, and I was
Yes.
absolutely fine with that. That's fine. That's what I want them to be. I think as a teacher, sometimes you feel like you have to have all the answers, but you really, really don't, and the children won't think any less of you for not knowing, for not being omnipotent and not being all knowing.
Yeah.
One or two of them might, but that says more about them than it does about you, Becky. I always think. Um, we have come to the end of another episode, Becky. That was fun. I enjoyed that.
It was a great episode today. And if you enjoyed today's AfterMaths, please do share it. And if you can give us a quick rating or a review, then we would appreciate it. It also helps new listeners to find the podcast as well.
It absolutely does. Last week, in case you missed it, we also went through some of our favourite things to teach, or maybe not favourite. They were the trickiest concepts in primary maths. So that was last week's AfterMaths episode 34. Go back and give that a listen. See if you agree with us on the 6 trickiest things to teach in primary maths. I was just thinking, Becky, we will need to do a Christmas episode soon. At least one Christmas episode, the maths of Christmas Day. If anybody has any ideas for maths that they see around Christmas, particularly, or a great maths puzzle that you've used with children to help celebrate Christmas, just let us know. Please get in touch. primarymathspodcast@twinkle.co.uk. That's twinkle without an E. Or find us on any of the social media platforms. We would love to hear from you. Without further ado, Becky, we will wrap that up and we will see you next week.
Thanks for joining us today.
Thanks. Take care.